Hello, everybody. My name is Wassim, and I have with me Jen from Tigera. Today, basically, we will present you a very easy and secure way to create multi-cluster Kubernetes. We have basically two levels of security that we will be presenting. The first one is how to create Kubernetes as a service with the fleet manager. And then the second level of security within each Kubernetes cluster, we will see how to secure it correctly with basically Calico. Very quick words about myself and Jen. So myself, I am Wassim Soualhi. I am a solution architect working for Mirantis, and I have with me Jen. Jen, if you could very quickly present yourself, please.
Yeah. Hi, I'm Jen. I'm a technical marketing engineer at Tigera. Spent a lot of the beginning part of my career in the geospatial industry before sort of getting into deploying some of those enterprise products in Kubernetes, and then ended up at Tigera. So been in the Kubernetes space for a few years.
Okay, thanks a lot. So let's start. Basically, let's start with like the basic, which is basically Kubernetes. With Mirantis, we have a K0S, which is like one single package, which is having all the dependencies. It's very easy to install. It has all like the needed components, and from the networking part, it has by default Kubrouter when you have like a small cluster, or it has Calico when you have like a big cluster. And I have put in here eBPF in purpose. Why eBPF? Because actually we have with Calico and we have basically eBPF, and we have and we have also IP tables and more. So a lot of people, they know already that it has IP tables, but when I discuss with basically the customers, they don't know that it has also eBPF. This is why I am putting eBPF here, and Jen will be able to talk more about it in the next coming minutes. One more thing, actually, it has etcd or KAI, for example, if you would like to use like some other DB, and it was like donated to the CNCF. So now it's in a sandbox. So this is very basic. So basically, if you need one cluster, you just run K0S start, and you have your cluster, which is basically up and running. And then you could secure it correctly with Calico. This is what will be explained later by Jim. So you could have also a more detailed like deployment with this like one single cluster. You could, I would say, like you could, for example, have a few VMs, and then you just need to inject the VM IPs to one YAML files, and then you are on K0S, and then you are on K0S CTR start, and here you go. You have your cluster, which is up and running. This is good. But our main topic today is how to create multi-cluster, right? And this is why we wanted to present you Cordant. What is Cordant? So Cordant is a distributed container management environment, meaning that it's a Kubernetes fleet manager. So how does it work exactly? It has three components, like three main components. The first one is called KCM. This is basically a cluster manager. It would help you to create the underlying infrastructure, and then it would help you to put, for example, a K0S on top. This is the first step. And I will show you a demo which will be, I think, better later on. Then we have the second step, which is basically the KSM. This is a state manager, and this would help you once you have your cluster which is up and running. This basically would help you to get all your on top of this cluster. And when I say the services, it could be, for example, NGINX, it could be Kubernetes, it could be Kong, it could be any like added components that you need to have a fully working Kubernetes cluster. Then, of course, if you have a fleet that it is up and running, you would be 100% sure that it is still up and running, and you would like to get an idea about the cost. This is why we are adding COF as well, which is basically for observability and FinOps. Of course, all of this is open source. You will be able to use it very easily, and I will show you in so the demo that it is coming. This is just another view in order to give you an idea about how it works. Basically, you have some infrastructure. It could be so it could be on-prem infrastructure. It could be just bare metals. It could be VMware. It could be OpenStack. For example, the demo that I will be doing today would be on OpenStack, but it could be always like on cloud with AWS or Azure or whatever. Basically, you name it, right? Why you name it? Because it is leveraging cluster API, right? As I told you, the first brick, which is called KCM, this is able to use cluster API in order to create all the underlying VMs and storage and load balancers and security groups and everything that it is needed. Then it's able to put the K0S cluster, the same K0S that I just presented at the beginning of this meeting. Now you have a cluster which is up and running. Then you leverage the second stage here in order to add all the needed services. And then you leverage the third stage, which is here, in order to add like a login, monitoring, and alerting. And you would be able to duplicate this, right? Meaning that you will have the possibility to create a Kubernetes as a service. So this is the first level of security, meaning that you have a new team. This new team will have his Kubernetes cluster that it is completely segmented from the other Kubernetes clusters. So this is like a very strong security between Kubernetes clusters. Then with Tigera, so later on, we would have security within the Kubernetes cluster with like the network policy and more that will be presented by Jen. So this is just another view to give you so more information. So basically, you as basically a technical lead, you just need to define a few templates, meaning that you define basically two kind of templates. You define the cluster template, and then you define the service template. Inside this template, you put, for example, this is specific template for example, OpenStack or AWS. Inside this template, for example, I would like to use a Kubernetes cluster with like 1.33. I would like to use small t-shirt size or a big t-shirt size. I would like to use like a separate a new VXLAN. I would like to use this, would like to use that. This is like a very small template that is called a cluster template. I will show you later on. And you define as well a service template. In this like service template, you say, for example, I would like to have NGINX version 1. something, for example. So once you define all these like service templates and you have your credentials that are also defined, you give it to the end user that would be able to leverage the cluster templates and the service templates that you already defined for them in a self-service way. So they just need to leverage the templates and create Kubernetes as a service. This is basically the idea. So as I told you, you have the KCM. In this specific case for the demo, it is leveraging. It is basically leveraging CAPI. That would be able to create all the infra, and I will show you as well. Then you have in the other side, you have the KSM that is basically able to able to create and manage the lifecycle all the existing services that you see here. One more thing, you could either create clusters, right, from scratch, or you already have some clusters and you just want to leverage the services part and the telemetry part. In this case, you adopt the cluster, meaning that if you already have like 50 Kubernetes clusters or whatever, and you just want to leverage the components that are on top, you would like to leverage the telemetry. In this case, you adopt them. And in this case, you will be able to leverage the services and the telemetry. So having said that, one more thing. Of course, we have documentations and we have catalogs. We have two kinds of catalogs. We have the infrastructure catalog, meaning that these are like the CAPI that we validated so far, and we have more. So this is, I think that this is an old one, right? We have VMware, OpenStack, AWS, Azure, we have GCP, and we have like a few. And we have also the catalog of the services, like available services. Of course, everything is open source. It's very, very easy to install. I will show you. And of course, we have telemetry. It's mostly based on OpenTelemetry. It's displayed with Grafana, and we use Victoria Metrics in order to store the data. So now let's move to the demo. So I'm having three clusters. The first cluster is what we call the mothership cluster. Maybe I will show you this is better. Yeah, I'm having the mothership cluster, which is here. Then I'm having one regional cluster. Regional cluster is used mainly for the login monitoring alerting. And then I have one child cluster, which is on, which is basically on OpenStack. So now suppose that I would like to create another child cluster. So as I explained you here, basically all what we need is to define a cluster, right? So we have already specific cluster templates that are defined. Let me show you what they look like. So if I come here, okay, get so cluster templates. Yeah, I can see that we have already a few cluster templates that were already like defined, right? One of them is this one that you see here. This is OpenStack standalone, meaning that this cluster template is able to deploy so OpenStack clusters with like workers and masters on top of VMs, right? So now let's define a new cluster. So as a user that is having like a self-service, you just need to define very easy so YAML file. This could be done also via GUI. I will show you the GUI later on as well, but I wanted to show the YAML file to explain better. So you just need to define a name. You define namespace where you are putting your cluster. And then you select your templates. This is the template that was defined by basically the technical lead. Now you are just like a user doing self-service. You define the credential that was defined also by so basically by your technical lead, right? And then you select so the t-shirt size and which kind of OS you would like to install, and maybe you would like to add some labels, and then you would like to define so the number of control plan and worker plan, and then you would like to define the Kubernetes that you would like to install, and you would like to define the subnets. This is basically a subnet that will be created. So say, for example, this like subnet that it is created. And here you could define, if you wish, extra services, or you could let them later on. So you could basically add them later on. I just need to apply and see the magic happening. So okay, apply. I add my cluster. It's called cluster 4. It's here. Yeah, and that's it. And then we could either follow it here on the CAPI visualizer, or we could follow it from the command line here on the CAPI as well. If I watch my cluster, I would see the cluster being created step by step here. So if I watch here, yeah, you would see that it would be so created step by step. And I can see as well in my OpenStack that everything is being created. So this takes roughly 5 minutes. You see, so I'm going to show the cluster that I created 40 minutes ago. So just before this, this demo. You could see here, for example, that it's created automatically. So the VM for the control plan, the worker as well, and it created the bastion, because basically it's only the bastion that is accessible through a public IP, right? And then everything is done through this bastion here. It has like it has selected the specific flavor, for example. It has created the network that I asked. So everything was basically done automatically thanks to CAPI. It has created all the networks here. It has created like the routers, whatever, right? Here basically we see that that everything is being created automatically. So this would take roughly 5 minutes. At the meanwhile, I will show you something else. Yeah, this is ongoing. We'll keep it ongoing. Yeah, this is cluster 3 that I added, as I told you 40 minutes ago. Now that I have my cluster, what I want, if I get back to this here, is that we have created the cluster. The cluster is up and running and happy. And now we would like to leverage the second brick, which is the KSM, in order to add services. So you will see that it's very, very easy to add a service. So here, for example, I have my cluster. It's cluster 3. And then I would like to add, for example, a service which is NGINX. So before to add the service, let's see all the services that my administrator has added. For example, if I do get service template, yeah, we see that I have these like services that are available. I can ask my manager to add another service. For example, if I need another service, for example, Dex, I can ask my my admin. He or she could go here, would find Dex, and would just install it. So installing Dex meaning that he would just install this Helm, copy like that, and would just install it, right? Actually, I can do that because I have admin capabilities, so I am able to add services, right? So here I will add the service, and then when it's ready, I can use it, or I can use like a service that already exists, right? For example, this like service here, it already exists. Let me add it, and I will show you how it works. Yeah, you see the new service that we just added. Now it's available here. But yeah, let's basically add this like service to our cluster. So this is the child cluster 3 that you could see here. Let me display it. This is the child cluster 3, right? It is here. It's a happy cluster, but it is missing like services. Let me add the service. I just need to add the services, right? So in this case, I am adding NGINX. I just need to apply again this YAML file. Yes, it's configured. And then what happens is that, what will happen is that this project Speltos that you could see here, it is doing reconciliation. And then it knows that it has to install NGINX, and it is installing NGINX, right? And this is how you could install new services. You could basically upgrade the new services. Yeah, you see now it is up and running. And I can go like that with other services. I could update them and these kind of things. So this cluster here might take like 2-3 extra minutes, but then it will be up and running and we will be able to leverage it.
Okay, so let me introduce Calico. So Calico is of a single solution that does all the networking, network security, has some observability in there as well, all within sort of a single platform. You can manage your sort of ingress and egress traffic as well as your sort of east to west traffic as well. So all of the traffic within your clusters, we can use Calico network policies to secure that. So you can kind of get a bit of an overview on this slide here. So Calico works across lots of different Kubernetes setups. So you can see that a lot of people are using different distros. You can see a lot of familiar names at the bottom there, which Calico works on all of them. You can see Mirantis there on the right-hand side. And again, different workload types as well. So not only does it work across lots of different distros, whether you're running in containers, VMs, bare metal, etc., Calico will work and give you a consistent experience no matter where your sort of Kubernetes clusters are being hosted. And I believe we already mentioned this in the sort of beginning today. There's lots of different data planes that Calico supports too, and it's quite easy to swap between them. So we do support eBPF. We have Windows HNS data plane, as well as Linux NF tables, IP tables. So lots of different options for compatibility there. So wherever you're installing your Kubernetes clusters, Calico should be supported, able to be installed, and then provide your sort of network security and observability there with it. A little bit of an overview about sort of what that network security observability means. So Calico is the sort of default networking plugin for MKE. So you may have been aware of it as a CNI. But with the recent release of open source 3.30, which if you're using that already or you can upgrade to use that, you do get some extra features that are sort of shown on this slide. So things like network policies we already had, stage policies, policy tiers, and I'll be talking about that in a little bit, as well as ingress gateway. Whereas with the commercial options, that's what you can see for a lot of these boxes here. So things like egress gateways, if you've got traffic leaving your cluster and you want sort of like a static fixed IP address, maybe to integrate with other firewalls, other SaaS services, things like that, where you want an easily identifiable IP address from that traffic going out of your cluster. And even things like cluster mesh. So if you're setting up, like we're seeing, like setting up different clusters connected to each other in different regions, high availability, disaster recovery, etc. Calico can help with this as well. So not only by federating services, but also with the network policies, you can build your network policies and have them apply that intent across clusters. So even if the clusters are in different regions or just different clusters, you can still write your network policies, use labels and things to identify the traffic in sort of a Kubernetes native way, and that will apply across all of your clusters. You don't need to worry about setting up like load balancers to go between different clusters and sort of turning it into north-south traffic. You can handle it as east-west. And then a few other things on here that I'll probably be better off showing you how that works and how you can use them to help with securing your Kubernetes clusters. So depending on how familiar you are already with sort of security and Kubernetes, a lot of people, if they come from more sort of traditional environments, might be familiar with using like sort of VLAN, subnets, ACLs, etc., to implement security. But these don't get granular enough sort of for east to west traffic, where you've got different workloads, different namespaces, etc., that might be able to talk to each other within the cluster. So by default, Kubernetes networking allows everything to communicate with each other within that cluster until you start adding in network policies for that security. So by default, everything is sort of like an allow all communication method. And then even then sort of setting up your subnets ACLs would help control the traffic as it's leaving your cluster, but wouldn't necessarily be the best option for within your cluster. And everything within your cluster you're sort of defining with labels. You're not really using the IP addresses because they're sort of ephemeral, dynamic, they're always changing. If you're scaling up and down, those IP addresses are going to be different. So being able to use sort of Kubernetes labels and things for your security gives it that identity-aware approach. And it's just much better for securing your Kubernetes clusters. So a lot of people typically, when I sort of present or do webinars, are newer to network policies. So I can start off just by showing you a bit of an example of a network policy for those who aren't as familiar. So you can see here we've got the API version set. So this is the Calico network policies, which give you a little bit more functionality over the Kubernetes network policies that you kind of get by default. And I think just in the range of selectors, you can apply Calico network policies globally. So you don't have to build them per namespace and give them a namespace scope. You can have them apply to the whole cluster. Now with 3.30, which I'll show in a little bit, we have staged policies, policy tiers for organizing, sort of controlling the order in which your policies get evaluated as well. So when you're building network policies, you can do this as a YAML manifest, which you can see here. And we can see the kind set to network policy. You give it a name. If it's a network policy, you'll also be defining which namespace this network policy applies to. And then you can use selectors to determine which traffic this policy applies to. So again, sort of no IP addresses listed here. Everything is being done by labels. So these policies will apply to any pod that has the app equals netshoot label on it. And then you can start to build out the rules. So you can combine ingress and egress rules into a network policy. And we just add these sections here, but just for an example, I've got them in 2 separate policies. So both of these policies are actually denying traffic. You can have rules for allowing, passing, or just logging traffic as well. You can define a protocol that you want to restrict or sort of control traffic on, and then either the destination if it's for traffic leaving your cluster, or you've got the source if it's traffic coming into your cluster. And then again, this is where you can kind of use that sort of Kubernetes identity-based rules here. So you can see that for this netshoot pod, we have netshoot pods in another namespace as well. As long as it's coming in with that label, that's okay. And again, you can add namespace selectors here. So traffic would be allowed into namespace A if it's from the default namespace and it is a pod with that label on it. And then similarly with this policy for egress traffic, but the opposite. So traffic is allowed out of this default namespace from the netshoot pod, as long as it's going to a netshoot pod in namespace A. And you can also build out more and more rules. It doesn't have to just be one rule per policy. And you can add sort of IP sets in here as well for egress rules if you know they're going to somewhere else and you have sort of like an IP range that you can define. It's kind of a bit of an introduction to network policies. And these network policies I've actually already applied to this cluster. So start off by sort of getting a list of all of those netshoot pods. So I have 3 of basically the same pod in 3 different namespaces. You can see I've got 1 in the default namespace, 1 in namespace A, 1 in namespace B. And I did the OY just so I can see their IP addresses, just so we can test communication between them. So sort of doing this, going inside the netshoot pod in the default namespace, and then just running a ping command and taking one of those IP addresses there to try and ping it. And then you can see it's kind of stuck there. It's not really giving us anything back. So I'm guessing traffic is not allowed to 130, which is the netshoot pod in namespace A. You can try again with 143. And then again, that's sort of getting stuck and that communication is not being allowed. So this is where sort of having access to flow logs becomes really helpful as part of that observability, not only for testing your network policies and sort of being able to see if traffic is being blocked, why, but you can also use this information to build your network policies in the beginning. So what you can see now actually is Calico Whisker. So in 3.30 with Calico open source, Whisker comes with it basically. So you'll just have this service running inside your cluster, which is Calico Whisker. You can go to your browser, navigate to this, and you have a nice UI just for viewing all of the flow logs within your cluster. So you get 12 hours worth of flow logs collected here for your cluster. You can add filtering by policy, namespace, where the traffic is going, etc. And all of the most recent flows you'll actually see listed down here. So we can see, actually, I've got other applications running in this cluster, but we were testing traffic going from that netshoot pod in the default namespace to namespace B. And you can see that that was actually getting denied by Calico. And if you want more information, you can click on any of these rows in the flow logs, expand it, and in the flow log, you get a list of all of the policies that have been applied to that traffic flow. So as you're sort of writing policies, you want to check that your policies are applying to the right traffic. You can go into here, have a look in the list of policies, make sure that you can sort of find your policy, have a look at what the action for that policy is supposed to be. So you can see I've got a lot of sort of past policies set up in here. I've got a deny on here. They sort of go along and just check that the policy is being applied to the right flow and whether it's having the right outcome. So we can see that this was denied. And this also is useful if I hadn't already built my network policies or applied them. You can come in here and look at the flow logs for how your applications are working right now. And you can see the sort of source namespace. You can see the destination namespace and names. You can see the labels. If I was able to scroll down here, you'd see the protocol, you'd see the ports. And that's all of the information that we saw in the network policy that you're defining to keep your cluster secure. And then you can build these policies to add security in a sort of like a namespace level, secure just the perimeter of your namespaces or your tenants, or you can go deeper with sort of workload level network policies or sort of microsegmentation, where you're saying within an application, let's say the database is only allowed traffic from specific pods that need to call the database. And then the database isn't going to have any traffic going out because it's just going to be receiving calls. So you can start to add a lot more granular policies like that. And then because you're using the labels, let's say you scaled up one of the pods or a front end pod, for example, to like 5 replicas just to be able to handle load, because it's going to have the same labels, those network policies keep applying to that traffic and your application is secure from the moment that it scales up. So again, just showing here, we've got some of the policies that are denying. Looks like we had a default deny policy in this cluster, which is denying the traffic here. So we also recommend, sort of one of our best practices for sort of Kubernetes cluster security is adding a default deny policy into your clusters. So you can do this sort of globally, and just sort of select out, I guess, critical namespaces, so things like kubedns, etc. Or you can do this on a namespace level. And then for each namespace that you're creating in your cluster, add a default deny policy so that traffic is denied by default. And then you're forced to build policies to only allow the traffic that you trust within that, just to help sort of close any gaps and keep your security, your sort of zero trust posture. So within Whisker as well, you can also click on the top here. You've got sort of the list of all of the flows, which we were looking at before. And then you can also flip over to a denied flows tab, and it will show you just all of the denied traffic flows in your cluster. So you can see here from sort of all of the testing that I was doing, I guess with the ping, it keeps trying to send that request out to see if it can communicate. We've got a lot of recorded deny flows here within here. So now we were looking at how it goes to namespace B. You can have a look at namespace A as well, or any other of the not denied traffic. So to prove that without the policies in place, the traffic is allow all, just doing a command here to get all of the Calico network policies. You can see here I've got a bunch in different namespaces, some of the policies that we just looked at, some for namespace A, some in the defaults. We've got the allow, netshoot, NSA, default deny that we just saw that was in the flow logs for the policies that was blocking one of the traffic. I'm just going to go and actually delete all of these policies. So delete the default deny, go and delete that allow, netshoot, NSA. And then we can go back and sort of have a look, filtered by the source namespace is the default. So if we're running those ping commands again, now we can see that it was denying some traffic. We sort of had those sporadically. And then we get a few flow logs in here that are showing allow. So we can see how that behavior changed pretty much instantly as soon as we deleted those policies. So then I could go in, make more policies, use all of this information in the flow logs to keep my cluster secure. That kind of shows you a bit of an introduction to network policies. If you sort of haven't seen network policies before, how you build those up as a YAML manifest, how, because they're sort of identity-based, you can sort of target the right endpoints. It's reliable, and you sort of get to do this in a more risk-free manner. So the ability to sort of look through the flow logs, get really detailed information on how communication is happening inside your cluster before building your network policies is really important. So people can feel a lot more confident when they're creating them and applying them in their clusters, that you're not going to start breaking applications because it's going to start denying everything or your rules weren't written correctly. And then something that also helps with this sort of, I guess, the confidence of applying them, being able to test out your policies beforehand, is staged policies. So again, you can now do this in Calico Open Source 3.30. Where we saw is we were sort of defining the policy before and it just had network policy, or you would say global network policy. If the kind is staged network policy, this means that the policy will sort of get applied into your cluster, but it won't actually start altering any traffic flows from the beginning. So you'll be able to go into the flow logs in Whisker like we saw, and you would end up seeing the staged network policy there, and it wouldn't actually be sort of blocking or allowing the traffic. It should show you what the outcome of that policy would be if it were enforced. So you can sort of add your staged policies into your cluster, go and verify in the flow logs before you actually start to enforce them. So again, just sort of more reassurance or insurance against adding in misconfigured policies, so that when you do that, you know that you're actually keeping your cluster secure. You're not at risk of sort of any unintentional outages or anything like that. Again, I can show you this one. So if I do a kubectl get staged network policy in my cluster, you can see that we've got some staged network policies. We'll be having a look at this one that's in for denying traffic for the voting namespace. That's in the vote namespace. There's an application installed in there. And I'm just describing that one. And then just so you can see that the kind is staged network policy. And then again, if we go back to Whisker, find some of the traffic that's in the voting namespace, you can see it down here, the staged network policy. So you can see that it's that vote deny policy. And then you can sort of just verify that, okay, I do have traffic going from that voting namespace or coming into that voting namespace, and we can see that that policy would have been applied. So I've probably got my selectors and everything set up correctly for that policy. And then if you want to sort of go and change it back, you want to enforce that policy with Calico open source, you would just go and edit this YAML manifest, remove the stage so it just says kind network policy, and then reapply that to your cluster, and then the policy would then be enforced. And then so one thing that I didn't actually talk about yet, and I think it's easier to sort of show you rather than on the command line, is for the policy tiering. So again, in 3.30 with Calico, if you're using that in your sort of clusters, you can now start to organize your policies in a better way. So you'll be able to, or you can see it in here, actually. This example here, it has a default dot before the name of the policy. And even in here, you've got default dot. So everything that's sort of a prefix before the namespace, before the name of the policy, sorry, is the tier. So you can actually start to group them together into tiers. So it makes sense if you're doing sort of application level security in your cluster, you can group policies together. A lot of people will add tiers for like a platform tier, a security tier. So if they've got more sort of organizational wide or cluster wide controls that they want to implement on everything, and they always want to make sure that gets evaluated first compared to policies that maybe the developers are writing, you can add those in tiers that sort of have higher precedence, basically. So they'll always get evaluated before anything the developers write. And then so yeah, just a sort of overview or recap of the microsegmentation and using network policies to segment up your clusters. You can do this at a workload level, which we mentioned, just by using all of those selectors, the labels, making sure they apply to specific pods within an application. Or you can do it wider on sort of like a more namespace tenant level. Support multiple data planes, so the network policies will work no matter which data plane you're using. You get Whisker in open source for sort of all those detailed network interaction insights. So we're not doing sort of application monitoring. It's just purely on the network, so you can see how they're all communicating with each other, supported on different environments. And because you're doing this as YAML as well, you can do this sort of policy as code to automate policy enforcement as well, which is useful for organizations who sort of have more of those CI/CD pipelines. And it's a little bit more automated. And then so paired with Calico open source 3.30, and this should work if you're sort of keeping Calico as your sort of default networking in your sort of MKE clusters, you should be able to connect to your Calico Cloud free tier as well. So you should have access to Whisker that will get installed with Calico 3.30 or above. But Calico Cloud free tier is kind of like a lightweight version of our commercial offering. And this makes it easier for me to show you policies, actually, or the policy tiers. So alongside the sort of list of flow logs that we just saw, in the free tier, Calico actually builds all of those flow logs into a visualization. So you can see in my cluster, I had that voting application. You can see now clearer sort of what other namespaces I had in here. I could double click on any of these and it would take me and it would show me all of the pods that are running inside of there and how they're communicating with each other. And you can see the sort of volume of traffic that's allowed or denied there. It has all the flow logs that you're used to seeing from Whisker so that you can sort of validate or use that information to create your network policies. You can see there bigger list of flow logs, different dashboards for sort of more monitoring over time. But the policies board is what I really wanted to show. So You can do this without Calico Cloud Free tier, and you can see how we define the tiers. You create the tiers via the CLI, apply them to your cluster. And then when you create a policy, you'll define which tier it goes in. So you can see I've got the default tier, which typically goes last. So any policies that don't go in any tiers before will get evaluated here. We've got a security tier on the left-hand side. So these will always get evaluated first. So policies go from left to right for tiers and then top down within each tier. So you can see that we've got some policies in here that are allowing external API access, for example, to trusted domains that will allow that traffic. You might have compliance policies in here, blocking things to threat feeds, so sort of known threats or malicious or suspicious IP addresses. And then within the platform tier, you might want to add rules to allow communication to kubedns, things like that, anything that's a bit more sort of platform infrastructure related. And then you can add tiers for each of your applications or tenants or namespaces. You can start to build those workload level policies. So you can see I've got a policy there specifically for the database, for a fact service, before it then gets passed to the next tier, which happens to be the default. So the policy tiers, alongside the sort of stage network policies, really allow you to sort of keep your policies much better organized. You can visualize them much better. You can assess the impacts a lot easier now if you're using Calico in your clusters, and then sort of help protect against the risk of misconfigured policies or outages or sort of security gaps. And then it only takes a few minutes to connect your cluster, which you can do to any 3.30 cluster. With that, I'll hand it back to the Mirantis team if you have any sort of last minute things, or as well as sticking around as well to answer questions in the chat if anybody has any.
Yeah, thanks a lot. It was very clear, at least for me. Yeah, actually, we have a free training now. So if you'd like, you just need to scan this, and it's like a 2 hours training. It's just click, click, click. It will give you very good information about Codant, about Cluster API, about Sveltos, and about all the components that I explained. And of course, you will have like a child cluster with Calico there, and I believe that you could test everything that Sujan explained as well. But if you have questions, please don't hesitate to send them here or to send them basically in LinkedIn or by email. We will be very happy to answer them and to connect with you. So thank you for your time.